Okay, here we are in our very last little lesson in our tiny little outcome here involving prime factorization. So we want to look today at square roots and cube roots, particularly square roots and cube roots of larger numbers. So I think we already kind of know what square roots are. These are numbers that, if a number is a perfect square, it has a perfect square root. So for example, 25 is a perfect square. And the reason that it is because we can create a square that has area 5 by 5, and that's where the actual square root comes from, is you can create a square. A perfect cube is any number that multiplies by itself 3 times to give you that number. So 64 is a perfect cube because I can create a cube that has a dimensions 4 by 4 by 4. So 4 to the power of 3 is 64. Therefore, 64 is a perfect cube. The square root, we use the square root symbol. It's the square root of 36 is 6 because 6 times 6 equals 36. If I have a cube root, you have to make sure that you include the little cube symbol. This is super important. It's a tiny little 3 on the tail of the root sign. It's not a 3 in front. We're going to be dealing lots with radicals and exponents in 2 outcomes from now. We'll look at this a lot more, but the cube root has the little 3 on top. And so the cube root of 125 is asking you what multiplies by itself 3 times to give you 125. Okay, so what I want you to do is pause this video, and I want you to write out the first, let's say 15 perfect squares. Okay, so for example, the square of 1 is 1, the square of 2 is 4, the square of 3 is 9, and so on. So I want you to go up to 15 squared. And then I also want you to do the first 7 perfect cubes. Okay, so pause the video now and write those down in the appropriate columns, and then we'll check them to make sure they are correct. Okay, so these are our first 15 perfect squares and our first 7 perfect cubes. Now when we get into dealing with smaller numbers that are square roots, these are numbers that you should recognize. Because we're going to be doing larger square roots and cube roots, we're actually going to use a method called prime factorization to kind of introduce it. Okay, so we're going to be building on what we were doing last week. And so we're going to take the number 1296 and we're going to write it as a product of prime factors. Okay, so remember we're looking for 2 numbers that multiply to give me 1296. Now I know for sure that 2 will go in because it's an even number, but because this is a bigger one, I'm going to take a minute or 2 on my calculator and try to find something bigger. So I'm going to start with 8 and 162. And then we break down each of those and we keep going until we get prime numbers. So 8 breaks down to 2 times 4. 162 breaks down to 6 and 27. Okay, and then I keep going. So the 4 breaks down to 2 and 2. 6 breaks down to 2 and 3. 27 breaks down to 9 and 3. And then I can keep going with the 9 to 3 and 3. So my prime factors are 2 and 2 and 2 and 2 and 3 and 3 and 3 and 3. Once we have that prime factorization, what we're going to do is we're going to rewrite our square root symbol, the number 1296, as a product of prime factors. So we're going to write it as, I have a total of 1, 2, 3, 4 2's. So 2 times 2 times 2 times 2 times 3 times 3 times 3 times 3. Okay, so I think we can all agree that if I multiplied all those together, I would still have 1296. Now, using the method of prime factors, the way that we determine square roots and cube roots is that we take 1 from each, we group them, and so for square roots, we group them in pairs of like factors. For cube roots, we're going to group them in trios. So since this is a square root, we're going to group these into pairs of like factors. So I have a pair and a pair and a pair and a pair. And then I'm going to take 1 from each group and multiply them together. So the square root of 1296 will be 2 times 2 times 3 times 3. So I've taken 1 from that group, 1 from that group, 1 from that group, 1 from that group, and I multiply that all together, and I get 36. Okay, a couple things I want to just point out here that are kind of important. Number one, make sure that that square root symbol goes all the way to the end of your numbers. Don't be making it short. Make sure it goes all the way. Notice in this step, I still have a square root symbol because I haven't completed the operation yet. Square rooting is an operation just like adding, subtracting, multiplying, and dividing are operations. So once I perform the operation, which is taking one of each thing out, then my square root symbol is gone. So notice in this step, the square root symbol is gone because now I have performed the square root. Okay, so let's look at the cube root of 1,728. So again, I'm going to break that into product of prime factors. We know it's even, but I double checked and I can get 6 and 288. Remember, if you see something different, you can definitely join us at the end. As long as we all get down to prime numbers at the end, that's totally fine. 288 breaks to 8 and 36. This keeps going to 2 and 4, 6 and 6, 2 and 2, 2 and 3, 2 and 3. Okay, so now I have my cube root of 1728 is the same as the cube root of. Now, I like to write them like with like factors next to each other. So I have a total of 6 2's. So 1, 2, 3, 4, 5, 6, and 3 3's. 1, 2, 3. Now remember, for cube roots, we're going to group them into trios because I'm looking for 3 things that times together. So I have a group of 3 2's here, a group of 3 2's here, and a group of 3 3's. So my cube root, now I'm going to perform the operation. So my root symbol goes away, and I take 1 from each group. It's 2 times 2 times 3, which is 12. Okay, and you can check your answer by saying 12 to the power of 3 on your calculator, and that should give you 1,728. Okay, let's try to do 1,764. So same idea, we're going to break that into its product of prime factors, which can be 4 and 441. This becomes 2 times 2. This is 21 times 21, which is 3 times 7, 3 times 7. Now we rewrite our number as its prime factors. So I've got 2 times 2 times 3 times 3 times 7 times 7. This is a square root, so I want groups of 2. So my square root of 764 is 2 times 3 times 7, which is 42. Okay, same thing. Cube root of 27,000. So I'm going to break up 27,000 into 27 times 1,000, 3 times 9, 10 times 100, 3 times 3, 2 times 5, 10 times 10, 2 times 5, 2 times 5. So I'm going to rewrite this as its product of prime factors. Let's go hunting for our 2. So I have 1, 2, 3 2's. And I have 1, 2, 3 5's. Or sorry, 3 3's. Eek, I'm kind of squishy here. And then I've got 3 5's. 5, 5, 5. Let's just pretend that goes down there. And I want to take my groups of 3. So my cube root is 2 times 3 times 5, which is 30. Okay, so that is using the method of prime factors to find square roots and cube roots of large numbers without your calculator. Okay, so now I'm just going to do a couple more examples and then you'll be on your way. So we want to use prime factors to determine if 1,444 is a perfect square, a perfect cube, both, or neither. Okay, so we're going to again start with our factor tree. So I take the number 1444 and we're going to break that down. So I know for sure that it's even, so I can divide it by 2. We'll just start there. Now 722 is still even, so it divides by 2, giving me 361. This is a tough guy. So 361 actually breaks to 19 times 19. Okay, so my prime factors of 1444 are 2 times 2 times 19 times 19. So now to determine if it's a perfect square, perfect cube, both or neither, I'm looking at those prime factors. So since my prime factors come in pairs, that means that this is a perfect square. Okay, if my prime factors came in groups of 3, it'd be a perfect cube. And if it was in both, if I could make groups of 2 and groups of 3, so if I had like say 6 of one factor, then it would be both. Okay. Last question, if I have a volume of a cube is 9,261 centimeters cubed, what are the dimensions of the cube? Okay, so kind of when we talked about the definition of what makes a perfect cube, it is because it has side lengths that are the cube root of whatever the volume is, 9261. Okay, so I need to find the product of prime factors for 9261. So 9261 divided by 7 gets me 1323. And 1323 can be divided by 9, and that gives me 147. 9 can break down to 3 and 3. And 147 divides by 3, 3 times 49, which gives me 7 and 7. Okay, so the side length of the cube will be the cube root of 9261, which when I write my product of prime factors, it's 3 times 3 times 3 times 7 times 7 times 7, which is 3 times 7, which is 21. So the cube will have dimensions 21 centimeters by 21 centimeters by 21 centimeters. Okay, I have also posted this video on our EDSB channel on the main page. So if you need to go back and look at something, you can go ahead and do that. You can go ahead and do the assignment now.